Welcome to another video. This will be in Fusion 360. So we are going to create a bowling ball. Within my previous videos I created the same bowling ball within CATIA, either by using sketches and projected sketches on the surface, or by using Boolean operation. And the last video is regarding imagine a shape workflow. So this is the faster workflow. I also have a similar video for SolidWorks. So this will be the bowling ball within Fusion. As we can see, I already have this texture as well. So I will create a new part. I will enable the reference and I will create a new sketch. So the sketch will be a circle. The diameter will be 220 millimeters. And I will also create a line in order to define the axis over here. So as we can see within Fusion, we have the line option over here. And if I will drag my mouse over here, we're going to have this snap to the middle. If I want to convert the line type, I can use this construction button. Or there's also the possibility to use the hotkeys. In this case, if I will press X, I can have this converted to an axis. But Fusion is a little bit different than CATIA in SolidWorks. That means we don't need to actually have a sketch with an axis. Therefore, I can leave this as a simple line. And afterwards, using the trim tool, I will cut half of this. And with the resulting profile, we are gonna enable a revolve over here. As you can see, the profile will be selected and we just need to define the axis. In this case, the axis can be the middle line. And we're gonna see how that sketch will be revolved. Now, to define the cutouts, I will create an offset plane starting from the X and Y plane. I will increase the offset value to 110 millimeters. And this plane will be normal to the top of the sphere over here. Therefore, I can create a new sketch within the newly defined plane. And within the origin, I will create a circle, a 20 millimeter diameter circle. Afterwards, since I am within the sketch, within the same sketch position at the top, I will create a new circle. Again, this will be 20 millimeters. If I'm gonna rotate, I will see that both of those circles are defined within the same plane. And I can also add some constraints all the way to the axis. To the x-axis, I will add 35. And also for the y-axis, the same value, 35 millimeters. Now I will use the mirror tool. So the object will be the circle, and for the mirror line, I can use the axis line over here. So this is similar to CATIA. Within SolidWorks, we had to draw an axis over there. Now, within Fusion, we can have those extruded cut. So we are going to use the same feature over here. We see extrude. We also have a hotkey, which is E. And for the profiles, I will select the three circles. And if I will move the arrow towards the, let's say, inwards to the object, we're going to see that this will be changed to cut. And we're going to have this red cutout area over here. So if I will make this minus 20 millimeters, we're gonna see how those will be cut. If you want to increase the value of the cut, we can always edit the feature at the bottom. So I will make this minus 40 in this case. Now, just like within my previous videos in CATIA and SolidWorks, if I will go and do a section analysis over here, I will have this flipped. We're gonna see that all the cuts are done like this, so on the z-axis. they are not normal to the surface of the sphere. Therefore, if you want to change the cuts to be created, let's say normal to, we have the possibility to do that. I will close the section analysis. So to do that, over here within the analysis, I can just hide the section, and that will clear the viewport. And within this extrusion, I will only have the middle cutout, since this was created directly on the tangent to the surface. So this cut goes to the z-axis. But for the others, I will create a new sketch. And over here I have the possibility to create a new sketch, for example, in the side plane over here on the X and Z reference. And I will create a point over here. So I can position that point, for example, over there. I can add some constraints for that point. As we can see, we're gonna add the 110 millimeters distance over here. So that means the point will be positioned directly on that outer surface. And afterwards, within the construction, we have the possibility to use a plane tangent to a face at a point. And we can select that point, the surface. Keep in mind that for the plane tangent to face at a point, both of those will be added over here. So face and point, there are no different fields for that. And now within the newly defined plane, I can create a new sketch. I will create a 20 millimeter circle. And if I will go with extrude cut, so inwards, for example, 40 millimeters, you're gonna see how this cut will go normal to the surface. Therefore, we're gonna have a cut that will look like this. Now we can also have this mirrored on the other side, but we can also do a different cutout. So if I'm going to use the mirror, in order to find the mirror within Fusion, we're going to have it positioned over here, and we're going to have over here, we can only mirror the features. In this case, the extrude cut over here, extrude 2. I can select the mirroring plane, which will be that one. And if I'm going to click OK, we're going to have those cuts within the bowling ball. Now, if you want to change the position of those cuts, we have the possibility to change the location of the point. For that, I will need to search the sketch where we have the point, which is this one. And if I will increase this all the way closer to the top, so we see the initial cutout over here. We have the point position over there. Afterwards, we're going to have those change over here. Now, if I would like to have the initial cutout no longer active, we have the possibility to come over here, have this suppressed. So we can suppress the initial feature. And afterwards, we can create an additional point for the other cutout. For example, I will create a new point over here. I will add that dimension all the way to the origin, so we know that we had 110 millimeters. And again, I will create a plane tangent to the point and the face. And over here, I will jump in and I will create a new circle. And with that selected, I will go inwards minus 40 millimeters, and that will define the cut. So this is what I like about Fusion, the ease of use compared to CATIA and SolidWorks in this case. Now to address also a fillet over here. So some dress-up features for the bowling ball. I have the possibility to select all those over here, add a tangency. So we have this tangent. I will just add a radius of 3 millimeters, and afterwards I will leave the tangency weight to 1 and click OK. And we're gonna see how we're gonna have that rounded edge. Now, to address the appearance, we have the possibility to either right click over here, afterwards go to appearance. We see the hotkey, the default one, which is A. And over here we can search for a material. In this case I will go for stone, granite, and I will use the blue pearl texture over here. As we can see, the material size is quite large, therefore we have a pixelated material over here. We can change the texture map controls for this one. As you can see, I will have this projected to be spherical, and I can also choose an axis. I will go for the z-axis for this case study, but the texture is still quite pixelated. Therefore, we can go back to the appearance. And over here we have the materials added to the design part, so I will double click on this and we can change the scale of this. I will type in, for example, 15, and we're gonna see how that texture will be wrapped. Since I have this map spherically on the z-axis, we're gonna have that texture point over here where the points are wrapped. Therefore, if you want to do a render and you don't want to have that visible, you can change the mapping. So over here within the mapping controls, I will just choose a different axis, for example the x-axis, and now the top won't have that problem, but it will be present on the sides. So this is a common problem within computer-aided design software, that it's a little bit trickier to do proper mapping for spherical elements. This is why it's important to use either software like Keyshot or Blender to address these problems. But overall, we see that for the modeling part, Fusion does an excellent job when we want to create some cutouts that go tangent to the face of the surface. So if I will go over here in a section, we're gonna see how those cuts will look like. So we have that initial cut, the second one over here. Also, a section in plane is a little bit off, as we can see, since this is done at an angle. Therefore, we could change the angle over here of the section cut to better visualize that profile. So we see with 5 degrees, I can go with it a bit more, so somewhere around 15 degrees we're gonna see that profile better for the other cutouts. Okay, so I hope that you enjoy this content, because I try to create the same object within various software and present the advantage of each solution. So I will position a similar video over here to the left. I will put the Fusion tips and tricks playlist to the top, and also subscribe button to the right. So thanks for watching, see you in the next video.